Video, I will do an example conducting a chi-squared test for independence. Example, is there a link between gender and pet preference? The following table represents data from 100 randomly selected adults. Conduct a chi-squared test for independence to test the claim that there is a relationship between gender and preference. In other words, the two variables are what we call dependent. So here you see the table, and the table is essentially, we have two categorical variables. So we have gender, which is broken up into male or female, and then we have pet type, so dog or cat. So these are two categorical variables in our table. And we can see from the table that for the individuals who identified as male, and there were 52 of them, 29 said that they preferred dogs given this choice, and 23 preferred cats. Secondly, we look at the other explanatory variable, which is female, individuals who identified as female. And among these 48 individuals, 19 said they preferred dogs and 29 said they preferred cats. So just looking at a table like this, it's kind of difficult for me to draw any conclusions about, just an intuition about what's going on. I'm going to use StatCrunch, and I'm going to summarize the data and use row percentages to help me have a better understanding of what is going on here. So I'm just going to copy and paste the important parts of the data. And here I am in StatCrunch. So I'm just pasting the data. So the commands I'm going to use are stat, tables, contingency, and since I have all the counts, I'm going to use with summary. Now what I'm going to do is I'm going to select the columns that have my counts. So that would be dog and cat. And notice the first column doesn't have any counts in it, but what it does have is it has the explanatory values for the explanatory variable. And so the first column gives me my row labels for the explanatory variable. So my row labels are in the first column. And I am also going to click on row percent because I am curious to see these numbers as percentages, because numbers alone don't really make that much sense to me. And then I am also going to click on something called expected count. And the expected count is basically if we assume that there is no relationship between gender and pet preference, it's just what we expect the counts would be in our table. And I'm also going to make sure chi-square test for independence is selected. So I'm going to select row percent, expected count, and chi-square test for independence, and I'm going to hit compute. Okay, so now if you look at the data readout, again, I'm going to focus on male. So that is one of my categories, or one of my explanatory variable. And if I look at the table this way, I can see almost 56% of the males prefer dogs. If I look down at the females, about 40% of individuals identifying as female prefer dogs. So we do see that it seems like 55% of males preferred dogs and 44% preferred cats. It seems kind of like the opposite thing going on with females. About 40% preferred dogs, 60% preferred cats. So it definitely appears like there is some sort of a relationship in the sample. However, that's not what we're doing the chi-square test for. We are trying to see if this relationship extends to the whole population of individuals, adults. And our sample size it's not too big. So I don't want to draw any conclusions prematurely. Just take note of the 56% minus the 40%, but there is a small sample size, so I'm not sure if this is going to extend to all adults. First step of the hypothesis test, we will state the null and the alternative hypotheses. For chi-square test, my null hypothesis hypothesis will always be that my two variables are not related, so gender is not related to pet preference. Or another way to say this is gender is independent of pet preference. So there's nothing going on, there's no relationship. My alternative hypothesis is that gender is related to pet preference, or in other words, gender and pet preference are dependent variables. The second step of my hypothesis test is I want to check the conditions for the chi-square test are met, so I can use the technology and the formulas from our text, and then I want to find the test statistic. For the chi-square test, the first condition that we are going to check is that the samples are random. So we are told that this is a random sample. The second thing we need to check is, are the expected counts, E, in the StatCrunch readout all greater than 5? So let's go back to StatCrunch, and you'll see on the bottom here, these are the expected counts. Okay, and you see 24.96, 27, 23, 24. These are all greater than 5. So the conditions are met, so we can proceed with the test. So again, looking back at the StatCrunch readout, if I just scroll up a little bit, on the bottom here, you'll see the chi-square test. The p-value is 0.1055, and the value that you see here, this is the chi-square test statistic. It is 2.6198, ... So this is our test statistic, and this is our p-value. Step 3 of our hypothesis test, we want to find the p-value and interpret it. So looking at StatCrunch, we just did in the previous step, we found that the p-value is about 0.1055. So there is, in other words, there is about a 10.55% chance of getting counts like those observed if the null hypothesis were true. So in other words, it would not be too surprising, about like 1 out of 10 chance, to get data like those observed if gender and pet preference are unrelated or independent. Step 4 of the hypothesis test, we just want to always draw our final conclusion. So we found that the p-value was 0.1055, and that is clearly greater than our significance level of 0.05, which is alpha. So the p-value is large. We do not reject the null hypothesis in this case, and we can conclude that there is not sufficient evidence to support the claim that gender and pet preference are related. In other words, that these are dependent variables.